I hope you found our coverage of core compute and network infrastructure services valuable. Let's now take a look at some of the AWS storage services. In this section, we will introduce you to two key AWS storage services, the Amazon Simple Storage Service, or Amazon S3 as it is known, and Amazon Elastic Block Store, or Amazon EBS. Amazon S3 provides a simple web services interface that can be used to store and retrieve any amount of data at any time from anywhere on the web. It gives any AWS customer access to the same highly scalable, reliable, secure, fast, inexpensive infrastructure that Amazon uses to run its own global network of web applications. There are no limits to the space you consume in S3, and there is no limit to the number of objects you store in S3. There is, however, a soft limit of 100 buckets per AWS account. A soft limit is a limit that can be raised upon request if required. A bucket is the name of a top-level container that you create in S3 to store objects within. The maximum size of a single object that can be stored in S3 is 5 terabytes. Amazon S3 is designed for 11 nines of durability and 99.99% availability of objects over a given year. You can use HTTP or HTTPS endpoints to store and retrieve any amount of data at any time from anywhere on the web. Importantly, Amazon S3 is highly scalable, reliable, fast, and inexpensive. Some very common use cases for S3 include providing storage for logs, backups, images, documents, AMIs, EBS snapshots, whereas some more advanced use cases include using S3 to store web page assets and to deliver a static website directly from S3. Amazon S3 stores data as objects within buckets. An object is composed of a file and any metadata that describes that file. To store an object in Amazon S3, you upload the file you want to store into a bucket. When you upload a file, you can set permissions on the object and add any metadata. For each bucket, you can control access. In other words, who can create, delete, and list objects in the bucket. You can also view access logs for the bucket and its objects, and choose the geographical region where Amazon S3 will store the bucket and its contents. The combination of a bucket, key, and optionally a version ID uniquely identifies each object stored in S3. In this example, doc is the name of the bucket, and 2006-03-01/Amazon S3.html is the object key. It is important to note that bucket names must be globally unique across all AWS regions and accounts. With Amazon S3, you have total control of who has what access to each object you store in S3. Encryption of data in transit to and from S3 is possible via the SSL encrypted endpoints for the S3 service. The encrypted endpoints are accessible both from the internet and from within AWS, so that data can be transferred securely both within AWS and to and from sources outside of AWS. Encryption of data at rest within S3 is available via a number of methods, and at no extra cost to storing data unencrypted. Customers who prefer to manage their own encryption keys can encrypt data before uploading to Amazon S3. Alternatively, you can use Amazon S3 server-side encryption if you prefer to have Amazon S3 manage encryption keys for you. With Amazon S3 server-side encryption, encryption happens automatically when data is written to S3, and decryption happens automatically when data is retrieved. Versioning is an S3 feature for keeping multiple variants of an object in the same bucket. You can use versioning to preserve, retrieve, and restore every version of every object stored in your Amazon S3 bucket. Lifecycle management defines how Amazon S3 manages objects during their lifetime. Some objects that you store in an S3 bucket might have a well-defined lifecycle. For example, if you are uploading periodic logs to your bucket, your application might need these logs for a week or a month after creation, and after that you might want to delete them. Some documents are frequently accessed for a limited period of time. After that, you might not need real-time access to these objects, but you might need to archive them for a longer period and then, optionally, delete them. Financial and healthcare records, long-term database backups, and data that must be retained for regulatory compliance are some of the kinds of objects that you might upload to Amazon S3 primarily for archival purposes. When you configure a lifecycle rule, you specify the storage class you want to transition the object to and the number of days after object creation when you want the transition to occur. You can transition objects to the S3 infrequent access storage class, archive them to Amazon Glacier, or have them permanently deleted. S3 infrequent access is useful for data such as backups and other older, infrequently accessed data where high performance continues to be a requirement. Pricing for Amazon S3 is made up of consumed storage pricing and request and data transfer pricing, with storage pricing for the APAC regions currently at a prorated 2.5 US cents per gigabyte per month. With Amazon S3, you pay only for what you use. Amazon Glacier is a data archival storage service. In the AWS Asia Pacific regions, it is currently priced at 0.5 US cents per gigabyte per month, offering extremely low cost archival storage for files requiring long-term retention. Using S3 lifecycle policies, you can easily have objects automatically transitioned to Glacier storage from S3 storage. When you have the opportunity, I recommend you investigate two new exciting AWS services that work together with Amazon S3. They are Amazon Athena and Amazon Macie, spelt M-A-C-I-E. The table displayed here details three storage classes that are available for S3 objects. Every object in Amazon S3 has a storage class associated with it. S3 Standard is the default storage class in S3 and is ideal for performance-sensitive use cases and frequently used data. S3 Infrequent Access is optimized for long-lived and less frequently accessed data, such as backups, and older data that is accessed infrequently but still requires high performance. Glacier is suitable for archiving data where access is infrequent and a retrieval time of several hours is acceptable. Archived objects are not available for real-time access. They must be restored before they can be accessed. Glacier storage is, however, very low cost. Now let's take a look at Amazon EBS. Amazon Elastic Block Store, also known as Amazon EBS, provides persistent, block-level storage volumes for use with Amazon EC2 instances and offers consistent and low-latency performance. EBS is particularly suited for applications that require a database, file system, or access to raw block-level storage. Snapshots taken of EBS volumes are durably stored and replicated in Amazon S3 in the same region as used for the EBS volume. For even greater durability, if required, These snapshots can be replicated to another region of your choice. EBS volumes can be attached to any instance in the same availability zone as the volume. Volumes attached to an EC2 instance are exposed as storage volumes that persist independently from the life of the instance. When EBS volumes are not attached to an EC2 instance, you pay only for the cost of storage based on provisioned size. Amazon EBS provides various volume types, which differ in performance characteristics and price, so that you can tailor your storage performance and cost to the needs of your applications. The volume types fall into two categories: solid-state drive-backed and magnetic hard disk drive-backed volumes. This table displays the characteristics of the different EBS volume types that are available for you to select when creating new EBS volumes. You can attach multiple EBS volumes to the same EC2 instance, but each volume can be attached to only one EC2 instance at a point in time. EBS volumes behave like raw, unformatted block devices. You can create a file system on top of these volumes, or use them in any other way you would use a block device like a hard drive. Amazon EBS is particularly helpful for database-style applications that frequently encounter many random reads and writes across the dataset. You should think of an EBS volume as simply a virtual hard drive. So a great use case for Amazon EBS is when you want the hard drive to persist past the life of the Amazon EC2 instance. EBS volumes are ideal for root volumes for your instance operating system, for database storage, and datasets that are up to 16 terabytes in size. Please note that Amazon EBS pricing is based on allocated storage. This is unlike Amazon S3, where pricing is based on space actually consumed. Additional charges apply for EBS with provisioned IOPS. Amazon EBS volumes are designed to be highly available and reliable. EBS volume data is replicated across duplicate storage systems within a single availability zone that you select when you create an EBS volume. This replication prevents the loss of data from the failure of any single component. Because EBS volumes are replicated within a single availability zone, establishing mirroring of data across multiple EBS volumes from within your EC2 instance's operating system will not significantly improve volume durability and is therefore not required. EBS volumes must be in the same availability zone as an instance to enable attachment. You can create point-in-time consistent snapshots of your EBS volumes to establish even greater durability than what is provided by a single AZ. EBS snapshots are stored in Amazon S3 and automatically replicated across multiple availability zones within a region. If required, you can even replicate these snapshots to other AWS regions for even greater levels of durability. The table in this slide illustrates the significant differences between Amazon S3 and Amazon EBS. EBS volumes are network-attached hard drives that can be written to or read from at a block level. Amazon S3 is an internet-accessible, object-level storage service. This means that you must write whole objects to S3 at a time. If you change one small part of a file, you must still rewrite the entire file in order to commit the change to Amazon S3. This can be time-consuming if you have frequent writes to the same object. S3 is optimized for write once, read many use cases. The other major difference is cost. With Amazon S3, you pay for what you use, and with Amazon EBS, you pay for what you provision. EC2 instance storage provides temporary block-level storage for your EC2 instances. This storage is located on disks that are physically attached to the host computer running your EC2 instance. Instance Store is ideal for temporary storage of information that changes frequently, such as page files, buffers, caches, scratch data, and other temporary content, or for data that is replicated across a fleet of instances, such as a load-balanced pool of web servers. Instance storage is very fast, it is free, but its contents do not persist if you stop and then later start an EC2 instance. The use case for local instance store is for temporary data only. For data that requires a higher level of durability, use Amazon EBS volumes or back up the data to Amazon S3. Finally, the table in this slide shows key differences between rebooting, stopping, and terminating your instance, including data persistence for Instance Store and EBS volumes. Awesome. In this second module, you learned about the key infrastructure services offered by AWS, including compute, network, and storage services.